Hola, hola, hola. Mis estimados. Welcome, everyone. It's good to see you again. How have you been? Okay, guys, we're going to continue with actually, yesterday we introduced the moment of inertia. We introduced how to calculate the rotational kinetic energy. And actually, we solving examples when we apply not only the kinetic energy, the moment of inertia, and also we learn how to apply the conservation of energy. But we have some news also, right? Because in this rotation of rigid bodies, we are not only applying by the kinetic energy or only for exclusive for the conservation of energy. Also, we can apply this rotational rigid bodies, but in this case, using the second level motion and torque. Okay, let me show you one singular example that involves the second level motion and torque. Second law of motion and torque. Remember when we are talking about the second level motion, my dear student, if you're thinking, okie dokie, mister, if I remember the second level motion establishes the force equals the product between mass acceleration. Yes, you're right. But if you're thinking, but mister, the second level motion, I strongly remember we created a free body diagram to determine what will be the direction of the movement, in addition X and Y forces, and after that to find out the magnitude direction of the acceleration. Yep, we applied all of this stuff in 6 months ago, if we remember, right? Today, the good news is that 90% of that process you learned already. Now, in this situation, we're going to combine the definition of force that will be mass times acceleration, and at the same time, the torque of the rigid bodies. Remember, torque can be combined by the product between the force times radio, and at the same time, the torque can be multiplied by moment inertia uh, times alpha. This is the combination between the second level motion and torque. For that situation, we're going to solving one singular problem, well, a classic problems that we're solving in the second level motion. Okay, let's see what we got. For example, we got two blocks, two blocks with with masses 5 kilograms and 5 kilograms and 7 kilograms and 7 kilograms, 5 kilograms and 7 kilograms are attached by a string, are attached by a string, by a string, as in figure, as in figure. Okay, over a poly, over a poly, over a poly of 2 kilograms, of 2 kilograms. If you remember when we studied the second level motion 6 months ago, we mentioned the poly with dispersible mass or without a mass, but this case, we're including the poly and the mass of the poly is 2 kilograms. Okay, period. The poly, the poly, which turns on a frictionless axle, turns on a friction force, turns on a friction, less axle, comma, is a hollow cylinder. So important thing, hollow cylinder with radius of 0.5 meters, 0.5 meters, over which the string moves without slipping. Period. The horizontal surface has a coefficient of kinetic friction. Coefficient of kinetic friction equals 0.35. 0.35. The question is, find the speed of the system, period. Find the speed of the system. Find the speed of the system when the block of 7 kilograms has dropped 2 meters. Okay, let's going to draw the picture, the problem. This is the table. This is the table. All right. And inside the table, we have this device. This device, that will be the poly. And in this poly, we have the block. The first block has a mass of 5 kilograms. All right. And we have the string involving around the body. Esta patita de la mesa. Ahí va. And we got the second mass. And the second mass is 7 kilograms. So obviously, this is the picture of the problem, and they're asking for what will be the mass, or actually the velocity of the block of 7 kilograms when it dropped a distance of 2 meters. Okay, obviously, at the beginning, a few seconds ago, before to release the system, the block of 7 kilograms starts from rest, right? But in actual, to tell you the truth, we have to looking for what will be the final speed. But how we can do this problem? Well, actually, my dear students, we're going to apply the knowledge that we'll acquire in the second level motion. First of all, remember, we have to establish what will be the direction of the movement. Obviously, 7 kilograms is heavier than 5 kilograms. That means The 5 kilograms will be moved to the right side. The right side will be positive, and the 7 kilograms moves downward. For that reason, the free body diagram for the 7 kilograms block will be positive in downward direction, because remember, in the second law of motion, the forces will be positive if and only if is moving or is applying the same direction of the movement. Opposite to the movement, that will be negative. Okay. In this situation, we have three bodies. We have the two blocks and the poly. We have three different bodies, so we're going to create three free body diagrams. Actually, if you remember, in the second level motion a few months ago, we established, because we were talking about the same string involving this poly, we were saying, this tension will be this one, that will be equal to this one. Yeah, in ideal conditions, it is. But in this case, remember, we're discarding the mass of the poly. But this case, we have to take a look what the problem says. Well, they gave us a radius, and also they're saying that this poly has a shape of the, let me see, hollow cylinder, right? So what does that mean? Because it's a hollow cylinder, that means we must to apply the moment of inertia of a hollow cylinder. Okay, but before to do that, let's going to establish the free body diagrams. Okay, so let's going to start with the first one. The free body diagram number one. We can take the reference, the block of 5 kilograms. Okay, we must establish the free body diagrams. Okay, so this is the coordinate plane. Because this block moves to the right side, okay, the sign will be the same. X positive, X negative, Y, and negative Y. What forces are acting in this case? Well, we got the normal force, upward, downward, the weight. So the weight of this block, that we must multiply mass times gravity, 5 times 9.8, that will be 49 newtons. 49 newtons. Obviously, the tension of this string that we're going to call this one like tension 1. And obviously, because we have in this horizontal surface, remember the problem says we have a coefficient of kinetic energy over here of 0.35 units. What does that mean? That means there's a presence of friction force in this situation. So we got the friction force. And this is going to be the free body diagram number one. And we can establish the system of equations. At the beginning, addition of the y forces over positive equals 0. And we got the normal force minus 49 newtons equals 0. So the normal force will be equal 49 newtons.
Mister,
Ajá,
¿qué es lo que pesa 2 kilogramos?
nada. Eso es la polea. As in a poly of 2 kilograms. The poly has a weight of 2 kilograms. Well, actually, not the pad. This is not a weight. This is the mass of the poly. Okay, and the block 5 kilograms, 7 kilograms. Okie dokie. Now x-axis. Addition, x forces to the right side positive equals mass times acceleration. Okay, we have the tension 1 minus friction equals the mass. This case will be 5 kilograms acceleration. Remember, the friction force is the product between mu k times normal. I mean, mu k is 0.35. And the normal force will be 49 newtons. That will be 5 kilograms acceleration. Okay, so what we're going to do? we can multiply 0.35 times 49. That will be 17.15. So subtracting passes to adding. We can conclude that tension one will be 5 kilograms acceleration plus 17.15 newtons. And this is going to be the value of the tension number one. Not big deal, not big situation, right? Let's going to apply the second free body diagram. Could be the poly or could be the 7 kilograms block. I'm going to use the 7 kilogram box. The order doesn't matter. Free body diagram number two. This case will be the block of 7 kilograms. Okay, then let's see what we got. We're going to drop the coordinate plane. And if you see, there's no movement in the x-axis. So x, negative x, but because 7 kilograms is falling down, downward is applying the same direction of the force. So over here will be positive and upward will be negative. Okay, what forces do we have in this situation? We have the tension number two, because it's located upward, and downward, the weight. In this case, 7 kilograms, right? 7 times 9.8, that will be 68.6. 68.6 Newton. This is going to be the weight in this case. Now, if you apply the additional forces, addition of y forces, downward positive, that will be equal mass times acceleration. What forces do we have? We have 68.6 Newton minus tension number two, because it's negative, equals 7 kilograms acceleration. And solving for the tension number two, we got 68.6 Newton minus 7 kilograms acceleration. That will be the tension number two. Remember, subtracting passes to adding, adding passes to subtracting. But just as I said, in this case, tension one is totally different than tension number two because we have a cylinder, a hollow cylinder, which affect the mass and obviously the moment of inertia. For that reason, in the free body diagram number three, obviously will be the body of 2 kilograms. What body I'm talking about? The body that I'm talking about the poly. Let me drop the cylinder or the how to say that, la palabra esta, el cilindrito ese, o por lo menos la parte de la polea. Va a ser como un circulito. Tururú, turú, tu, turú, tu. Turú, tu, turú, tu, turú, tu. Ora, ta, tara, ta. Ora, ta, tara, ta, tara, ta. Tara, ta, tara, ta. All right, this is going to be the cylinder. Okay, the part of the poly. Okay, in this free body diagram, okay, my dear students, we're going to apply that third level motion. For every force on action, we're going to have a reaction force. What I'm trying to say. So if you see it with the logical sense, okay, this force that's supposed to be the direction of this force will be to the right side in the free body diagram number one. So the reaction force, that means I'm going to apply the opposite. I'm going to say, okay, the force one or the tension one will be located to the left side, just as Samantha was speaking, okay? And and by one hand, and by the other hand, the second force over here is downward. We can apply this one like a upward, or in this case downward. Well, actually, porque esta sirve como un contrapeso, este la voy teniendo, pero este no sirve nada. Esta va a ir hacia abajo siempre. It will be located downward. The tension number 2. You're going to say, but mister, this 5 kilograms move to the right side. Yeah, but remember there's a friction force, so they're going to retarding that movement. That's going to happen. They're going to delay the rotation of this disc. That's why we are using this rope in the opposite side, because there's a friction force. Same happen over here. This force will be downward, but there's no, how to say that? No hay una oposición. Es ilógico que podamos decir que esto y que va a ir para arriba, no es cierto. Siempre tiene que haber una torsión opuesta que la otra. Okay, so in the free body diagram number 3, you're going to apply the addition of torques. Remember, in this situation, the addition or resultant torque counterclockwise positive, that's supposed to be equal iota times alpha. Addition of torque. What will be the torque? For example, if you see in the first picture of the problem, get it over here, the tension 1 produces a movement against the counterclockwise, right? So the torque number 1, that will be positive. The torque number 1. Again, if you put the reference point in the radius, torque number 1 moves to the left side. If you see, we are counterclockwise. That's why the torque number 1 is positive. And if we apply this situation over here, point reference the radius, that will be clockwise, right? So the torque number 2 will be negative. Okay, and how about the resultant torque? Who's heavier? 5 or 7? Obviously 7 kilograms, right? So the final behavior for this circle, or somebody was speaking on this cylinder, will be clockwise, right? Because this is going to be heavier, this is going to falling down, this is going to be the left side, but that resultant torque will be negative iota times alpha. Before to continue with this free body diagram, understood why the symbols of the torque? Yes or no?
Mister, ¿por qué la iba negativo?
Porque al final, mira el dibujito. ¿Para dónde se va a mover este bloque de 7 kilogramos? Para abajo,
Para
¿cierto?
abajo.
Y el de 5, ¿para dónde se va a mover? Para la derecha, ¿no? Entonces la rueda, usemos lógica, ¿cómo va a rodar? ¿Va a rodar así o va a rodar así?
Para la derecha.
Correcto. Y si usted lo hace para la derecha, ¿va a favor o en contra del reloj?
A favor.
Por esa razón es que se le agrega el signo negativo. Acuérdense que una torsión que va a favor del reloj va a ser negativa. E iota por alfa viene siendo torsión. ¿Entendió?
Sí, gracias, mister.
Okay. Now this negative sign, because it's multiplying with passes to divide, what's going to happen? We're going to change torque 2 minus torque 1. That will be equal iota to alpha. Okay? Because positive times negative, negative, negative times negative is positive. Now, what is the formula from torque? Torque equals force times radius, right? Or tension 1.
Mister,
Yep.
¿cómo hizo que ahora fuera positivo? No,
Ah, es que el signo negativo lo mandé a dividir al otro lado. Con un negativo 1 imaginario. Entonces, menos por menos, más y más por menos, menos. O podemos multiplicar por menos 1 a ambos lados para que te quede positivo.
Y no cambia el signo del otro lado.
Y cambió. Mire, ve. Aquí decía torsión 1 menos torsión 2. Ahora dice
Ah,
torsión
sí,
2
no me di
menos
cuenta.
torsión 1. Sí. Ahora, en vez de poner torsión, ve qué bruto. En vez de poner torsión 2, puedo utilizar fuerza por radio. En este caso sería, la fuerza sería tensión 2 por el radio menos tensión 1 por el radio. Usando esta de aquí. Solo en vez.
Mister,
Ajá.
¿puedo volver a explicar por qué la I va negativa también?
Ah, bueno. Fíjese bien el comportamiento del dibujo. Como 7 kilogramos va para abajo y 5 va para la derecha, ¿cómo se mueve la rueda? Piense cómo se movería. Se mueve para
Para
adelante.
abajo.
Bueno, se mueve así, ¿no? ¿Sí o no?
Sí,
Bueno,
sí,
la rotación es así. Ñin, ñin, ñin. Y esta rotación es a favor o en contra del reloj.
a favor.
Entonces, por eso que se pone negativo. Por eso.
Ok,
Dale, pues. ¿Hoy sí? Hello?
sí.
Okay. Now, continue with this equation. We can take common factor. What is the common factor between these two terms? Is the letter R, right? R parentheses tension 2 minus tension 1 equals iota times alpha. And because this letter R is multiplying, passes to divide. I mean, tension 2 minus tension 1 equals iota alpha divided by the radius. Okay, but this is the moment of truth. Would you like to tell me, guys, what is the moment of inertia? The moment of inertia of, what is the hollow cylinder? Remember it says hollow cylinder. A ver, ustedes se supone que tienen ya la tablita. ¿Alguien que me diga? A ver, alguien que me ayude. Hollow cylinder. En la
Mass,
figura que le mandé, pues ayer. Vamos a ver.
mass times
Mass times
radius
radio, right?
squared.
Yeah, because it says solid cylinder, yeah, because it says hollow cylinder, mass times radius square. Perfect. Hold on. So this is going to be the moment of inertia of the hollow cylinder. Remember, iota will be equal mass times square radius. Okay? Because hollow cylinder, es un cilindro hueco. So what we're going to get? Well, simple. Tension 2 minus tension 1 equals mass square radius alpha divided by this radius. Okay, and what happened with this square radius? It can be canceled with the radius, right? And we got tension 2 minus tension 1 equals mass parenthesis radius times alpha. Aquí lo puse en paréntesis por a propósito. En vez de poner MR paréntesis alfa, lo mismo por poner R por alfa. ¿Por qué? Porque si ustedes recuerdan, el parcial pasado les enseñé a ustedes la relación que hay entre la velocidad lineal con la velocidad angular, que era omega por radio. Y lo mismo la aceleración lineal o tangencial, que esto era alfa por radio. Como da lo mismo decir alfa por radio que radio alfa, ¿qué quiere decir eso? Que en vez de poner Jesus, R por alfa, voy a cambiar por la A de aceleración. Simple matter words, we got tension 2 minus tension 1 equals, what is the value for the mass? Mass of the poly, 2 kilograms, right? And this is going to be the acceleration. Now is the moment of truth because we have the first and second free body diagram, I mean the blue one in the purple formula, we're going to replace them. I mean, we got 68.6 Newton minus 7 kilograms acceleration. Okay, we'll be subtracting these two terms. Please be careful because this is negative and both positive, both will change the negative sign. I mean, negative 5 kilograms acceleration and also negative 17.15 newtons. That will be equal to 2 kilograms acceleration. Why both are negative? Because the area of the formula, if both are positive, negative times positive is negative, and negative times positive will be negative. And we got like terms. What will be the like terms? For example, we can subtract 68.6, subtracting 17.15, and the answer will be 51.45. 51.45 newtons by one hand. By the other hand, negative 5, negative 7, negative 5 is negative 12. Pass it to the other side, we'll be adding from 2, it will be 16 kilograms acceleration, right? And 51.45 divided by 16, the acceleration will be 3.22 meters per second square. This is going to be the acceleration of the system. But we are not, this problem is not over yet because the problem never asks you for what will be the magnitude acceleration. Remember the problem says, find the speed of the system when the plug of 7 kilograms has dropped or is falling down by 7 meters. So if we take the load, the initial velocity at the beginning, start from rest. The acceleration will be 3.22 meters per second square. And the distance is 2 meters.
Mister,
Ajá.
¿cuánto le dio ahí de kilogramos por aceleración?
16. Ahí, 3.22.
¿Pero por
Divida
qué 16?
porque menos 7 menos 5 es menos 12. ¿va? Ese menos 12 lo manda a sumar, se vuelve positivo 12. Ay Dios, perdone, ¿cierto, hombre? Qué bárbaro. Disculpe, 14, qué barbaridad, aplazado en la suma, qué barbaridad. ¿Cierto? 51.45 entre 14 la cosa. Sería 3.68. 3.68. Ahora sí. Ok, 3.68. Okay. Meters per second, and the problem asking for what will be the final velocity. Bueno, ¿y cómo hacemos eso? Facilito. Recuerde que tenemos esta formulita. Velocidad final cuadrado igual a velocidad inicial cuadrado más 2 veces aceleración, distancia. Y como esto vale 0, entonces la velocidad final es la raíz cuadrada de 2 veces la aceleración, que es 3.68 metros por segundo cuadrado por 2 metros. Así que la respuesta es 3.84. 3.84 meters per second. And this is going to be the final answer, 3.84 meters per second. ¿Preguntas?
Mister,
Dígame.
en la parte de las tensiones, en la parte de la derecha, ¿cómo sacó tension 2 radius minus tension 1 radius?
Factor común, como la R se repite, Recuerde que sacamos factor común o copiamos una. Y el paréntesis viene siendo el resultado de dividir cada uno entre factor común. Es decir, T2R entre R solo le sobra T2. Menos T1R entre R solo le sobra T1. Así.
No, pero en la parte de arriba.
¿Cuál? Esta.
Sí, esa.
Esta formulita, torque igual a fuerza por radio. Solo que la fuerza, acuérdense que son las tensiones. Y como que decía torque 2, lógicamente se puede poner tensión 2, que es lo mismo que decir fuerza 2.
Ah, ok.
Por eso,
Gracias.
dele. ¿Alguna otra pregunta?
Mister,
Ajá.
una pregunta. ¿De dónde sacó los 49 newtons?
49 newtons. Los 49 newtons es peso. Acuérdense que peso es masa por gravedad. Y si usted multiplica 5 por 9.8, le va a dar 49. Por eso.
Ah, ok.
Y lo mismo pasa con el 68.6. Si usted multiplica 7 por 9.8, le da 68.6. ¿Alguna otra preguntita? ¿No hay preguntas? Bueno, entonces el día de mañana vamos a hacer otro ejercicio. Uno que tenga una poleita con una sola tensión. Después vamos a hacer un plano inclinado con poleita. Y después vamos a hacer lo que es la famosa máquina de Atwood. ¿Se acuerdan cuando solo ponemos la polea y dos masas colgando? Bueno, esta vez la polea va a involucrar con las dos masas colgando. ¿Ok? Bueno, mis estimados aprendices, eso sería todo. Dios los bendiga, los guarde, los cuide. Entonces los estaría viendo. Bueno, mañana qué día es? Mañana es jueves, ¿verdad? No, hoy es
Mañana es
jueves.
viernes. mi.
Sí, ya estoy quedando loco. Entonces los veo el lunes, si Dios lo permite. Porque mañana no hay clases de physics, es verdad. Bueno, cuídense. Bye bye. So long. Take care of yourself.